Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard. Today we are looking at this question. It comes from vertical projection. Okay, let's look at the statement. Ball X is thrown vertically upwards from height h with an initial speed of 22 meters per second. At the same instant, a second ball y is dropped from the same height as shown below in the diagram. Okay, 4.1. Calculate the distance between x and y when ball x is at its maximum height. Okay. This is what we are having. We are having ball x projected, reaches maximum height, then drops and hit the ground. Then you have ball y at the same height. So as ball x is projected upwards, ball y is dropped, both taking place at the same instant. Now the question says that calculate the distance between x and y when ball x is at its maximum height. Okay, so when you look at this question, let us analyze it a bit. Okay, you look at the common factor between ball x and y. What is common? What is it that these two motions described? What are the two motions? As ball x moves to maximum height, ball y drops a particular distance. What is common between those two motions? So, time happens to be the common factor. The time taken for the ball x to move from point of projection to maximum height is the same time taken for the ball to drop that height, that displacement. Okay, so if time is the common factor and we don't have it, where do we get it from? Okay, if you analyze the two balls, which can give us time? It is ball x. Because ball x moves to maximum height, we have to the two velocities. You have the g, and what you're missing is delta t. Remember, for equations of motion, once you have three specified variable, the fourth one is known. Okay, let's start from there. So that's it. Time is the common factor, and that time is obtained from ball x. So that's it. Time is obtained from ball x. So let's look at all the variables which are going to give us ball x from time from ball x. So the factors we have, what do we know about ball x? Okay, we know initial velocity, which is 22 meters per second. Okay, what else do we know? We know final velocity because we are talking about maximum height, which is 0 meters per second. What else do we know? We know our g is going upwards, which is negative 9.8 meters per second squared. And then our unknown delta t. So when you look at this data, which equation is this one? It happens to be the first equation. What does it say? Vf is equal to Vi plus A delta t. This happens to be that. Then after substitution, this is what we get. So delta t is now known. And what is it? So we have the time, which is 2.245 seconds. So let me explain what this means. It means that this ball X, we are going to calculate the maximum height, and we add it to the displacement covered by ball Y in that very time. After that, what do? You add the two displacements. Okay. So what do? Let us divide this one into two. This side, let us call it ball what? Ball X. And we are calculating displacement. What do we know? We know Vi, which is 22 meters per second. We know Vf, which is 0 meters per second. We know G, which is negative 9.8 meters per second squared. Now, when you look at this data, what equation is this one? It's the second equation, saying that Vf squared is equal to Vi squared plus 2A delta X. Substitute, this is 0, 22. So when you substitute, this is what you get. So our delta X is going to be equal to, let us see. Okay. This is what we are having for ball X. The displacement covered to maximum height, it is here. Okay, let's go to ball Y. What do we have? So we say ball Y. Okay. First of all, we know that we are going to cover displacement in that time, which is 2.24 seconds. What else do we know? We know G, which is 9.8 meters per second squared, because it's going downwards. What else do we know? We are looking for delta X, so it's one of the factors to consider. And what do we know? We know the initial velocity. How do we know it? They said ball Y was dropped. Dropped means initial velocity is 0 meters per second. So when you look at this data, what equation does it give you? It gives you the third equation, which says that delta X is equal to Vi delta T plus a half A delta T squared. When you substitute, what do we have? We are going to have 0 times 2.24 plus a half times negative 9.8 times 2.24 squared. And what do we get? Let us see what we get. So this is what you get as the displacement covered by ball Y as it goes down. So from here you have to realize something. Let us look at here. As ball X goes upwards, covering displacement delta x1, ball Y is moving downwards, covering displacement delta x2. So when the question comes and it's looking for the distance between the upper and the lower, you are going to find yourself adding the two. So you're going to say that displacement covered, the distance between the two, is going to be delta x1 plus delta x2, which is going to be 24.69 plus 24.59, giving you, let's see what we get. So after adding, we have this as our distance between ball X and ball Y when ball X reaches maximum height. That's how we tackle that question. We are going to cut this video here. More questions on the same setup are going to be coming. Don't forget that the channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard. See you next time. Bye-bye.